So, Mike Walton, pick and place machine, take one.
Okay, so normally if I'm making a one-off prototype, I'll do it by hand. But normally if it was going to be any more than one, it's really not economical to do it by hand, so I'd use something like a pick and place machine. What happens with pick and place machine is we have the boards, and normally they're stacked up in a panel. So I wouldn't do a singular board, I'd have a panel which has all these boards locked together. And normally these will be able to, as you can see here, this is what we call a V-score. So when I've finished with it, I can just snap that board off, yeah? So they would be all tied together, and I would stick them on the bed of here. And this machine is a pick and place machine. It knows all the idents of the components because we can export that from our circuit, like multi-sim. We can export a pick and place file and import it into here. And then we tell this machine that in bay 1, we have the capacitor, the C1. In bay 2, we have the capacitor, the C7. Yeah, so we program the machine like that, and then we press play, and this machine will pick up the component, orientate it using the eye, and putting it in the right place. But before we do that, we need to have solder paste on it, don't we? So we've created the panel, and then we've had this shim, or stencil, created as well. And so what would happen is this panel, this would fit exactly over the panel, and then these gaps that have been drilled or cut into this shim would match up with the pads on the board. And we'd put a dollop of solder paste there, and we'd get a big squidgy, and we'd drag the solder paste over it, which would force the solder paste through all of these gaps and be exactly the right amount, and you'd know the right amount by the thickness of the shim, as to every single pad would have the same height of solder paste, yeah? And then we'd put that in the machine, and this machine would do its job. It would place those components on top of that solder paste, because the solder paste hasn't reflowed at this point. After all that's done, we'd carefully take that panel up and we'll place it into a reflow oven. Yeah, and so if you pull this out here, you can see, we'll place it into there, yeah, and we'll press play. And what the reflow oven will have is what's called a reflow profile. And a profile is like a graph. And the graph shows the temperature pattern the oven wants to follow. So there'll be a rise where it takes the mass of the board and puts some heat into the entire board, and then it will start to peak, and when it's peaking, that's the reflow temperature based on the solder paste we've chosen to use, and everything will reflow, and it will cause surface tension on top of the molten solder, and that surface tension will pull all the components into exactly the right position. It's a really good video to watch on YouTube. Look at surface tension and you'll see it all happen. And then afterwards, it will hold it at that temperature for a little bit, and then it will do a cool down period, and then it will all lock into place. And so that temperature profile is what we call the reflow profile. So depending on what type of components you've got, the thickness of the board, all these kind of things would determine that kind of reflow profile that we're going to use. If you had a plastic component or something, we need to be careful in the reflow oven because we don't want to melt plastic. If we don't, maybe we can get it through there quicker. Yeah. So that's how the automated process would do that. If you wanted to make a shim, when you uploaded your PCB file to PCBWay, there's simply a tick box on the bottom that says includes shim or includes stencil. And if you tick that, PCBWay will cut one of these for you for your board and send it to you. You'll pay a little bit more, but they'll send it to you for your board. So you'll have the perfect shim for your PCB. Yeah?